yourself.
Thank you, sir. First of all, good afternoon to all. And I would like to thank the organizing committee, especially Dr. R.K. Singh, for reaching to me and providing me this opportunity to be the part of this prestigious conference at Ahmedabad University. So, first of all, I would like to mention here that in this last 2 days of the conference, this today to the second day today, many things has been come across about the composites. People have almost spoken everything from from the manufacturing and to the recycling. The one thing that has been given a least, you can say, attention. I will appreciate one of the professor. I think some university yesterday has given the presentation on engineering the interface. This is very important area where students can do lots of research and with the various types of resins and various types of reinforcement because this is the one that responsible for transferring the properties from the fiber to the matrix or the resin so-called, and that will decide the ultimate mechanical properties of the material that based on the application is intended. So we'll try to focus on this aspect here. Though this aspect initially what I plan to present is not the one. This was not at all included in this in that presentation because most of the thing has been already gone through. So then I thought that it should be something unique. So let's go with that. So in this presentation, we are going to look at the Indian composite market overview that already everybody knows, and from the last last day and the previous day as well as today, people have put the forecast and more out, so it will be a little bit simple. So then the introduction to advanced composite, then design principle of composite, which is very important part as far as the fiber mechanics and the physics is concerned. Then primary raw material that are used for the composite like glass fibers, aramids, and carbon, and many other high performance fibers. So, and the next that preforming technology, which must be the key focus of the composites because it is an indivisible part of the composite. Without the engineered preforming, one is not able to attain the required property for any of the sectors that are the applications. Then there comes the processing technology. The processing also have lots of pediments that RTM, VARTM, and so many other processes are there. But in this presentation, I would like to put the out of autoclave, which is the cheapest and easiest and shortest mode of producing composite that have equivalent properties, almost equivalent properties, like for the with respect to the autoclaves that are used in the aerospace industry. And then the key technical and industrial challenges that India is going to come across, then strategic outlook and the opportunities. There are a lot many in the previous presentations, a lot many the eminent speakers have put a light onto the strategic outlook and the opportunities. So I will not give much importance to that. Then so here you can see that the growth chart of the 2 by 20 to 230 where the composite market is going to reach around 3.0 billion USD. And these are the areas that Indian composite industries are looking for 25% towards the aerospace and defense, 20% towards the automotive, 30% to the wind energy, 15% to industrial rail and others. So out of that, these are the percentage that acquire sector-wise, the percentage that is listed here. Not all of them are the high performance materials. that I think that remark would be contradictory. But it is fair to say that the proportion does not, to some extent, it may be in very small areas. This can be true, but majority of the when it comes to the large structures, this is not at all true. So the high performance composites need engineered preforming. So let's go to the advanced composite introduction. So advanced composites are engineered materials. Those have ability to replace the primary, secondary, and tertiary load-bearing structural component in an application. That's what actually the components came to the material domain to replace the primary, secondary, and the tertiary load-bearing structures. But the direction has gone to some other side. So advanced composites that are manufactured using pre-engineered and near-net safe continuous fiber preforms made from carbon, glass, aramid, and thereof. Combinations can be there in order to have the economicity depending upon the application sectors. So pre-engineered dry fiber. These are the preforming is a pre-engineered dry fiber coupled with liquid LCM, liquid composite molding techniques using thermoset and thermoplastic polymer matrices, offering potential for low cost and mass produced composites. Advanced composites offer high directional strength to stiffness to weight ratios, increased energy absorption, enhanced delamination resistance, thermal stability, and fatigue. So this is what the very important aspect of designing the composite. Yesterday, there was some discussion here going on about that doing an if suppose somebody is need to given a task. So what the person should from which outlook it should look at the aspect or the application. So this is the key there. So if suppose a component need to be made for the aerospace, or if it is well known, then the like that an analysis of the environment is very important, because the analysis will provide you the background. So what to select, what raw material to select, what should be the preforming structure, what should be the resin, and what kind of a processing method one is going to use. So here you can see that the fiber volume fraction, which is very important for the composites to attain, so that they have properties, they can attain properties that are for which they are intended. So here you can see that the arrangement of fibers. You have bidirectional fibers, unidirectional fibers, and the proper how the property varies with non-woven fabric, unidirectional pre-preg, fabric in 0-90 directions, quasi-isotropic. So three levels that fiber orientation includes random orientation, nearly isotropic properties. That's what with the this warp knitted multi-axials. They are known for that isotropic kind of properties, because the fibers the place, but the important drawback there is that they don't have a component in the thickness direction. So compressive properties are always on the back end. So cross-ply, transverse isotropic, then unidirectional orthotropic materials, then effects of anisotropy, how this direction of the directionality affect. So aligning the fibers along the direction of the load, unidirectional composite produce highest properties. To some extent, this is also sometimes contradictory, but most of the times they are proven. Perpendicular load carrying property becomes rather poor. Properties can be improved by placing fibers in transfer, but lowers the effective properties. So there must be a balance to be made in between the longitudinal as well as the transverse direction properties, the fibers, so that the material can give you nearly isotropic properties. But along the side, when we talk about the woven preforming, that gives you a third component, that is the through the thickness component. So the impact properties, delamination properties, and our damage tolerance comes into the picture. These are the various raw materials that we already familiar with this, the carbon glass aramids, and then the basalt fibers, natural fibers, and hybrid reinforcement. Depending upon the requirements, one can have various combinations in this direction and then produce the materials for variety of applications. So this is the preforming technology. Advanced preforming involves shaping reinforcing fibers because the fibers that are available are in the toe form. Am I right? A single toe form. Now that single toe, how you tackle that, that is very important. So that application will give you the idea, or the application environment will give once the idea that what should be, what one can do with the fiber. So into near net shape preforms before resin infusion, ensuring precise fiber placement, and optimized mechanical properties. So that is the directionality aspect. Advanced preforming is crucial for high performance composite in India, aerospace, defense, automotive, renewable energy sectors. The technology is largely imported. Opportunity exists for indigenization, skill development, and automation driven production, aligning India with global composite needs. So this is the framework of the preforming technology, how the fiber is put into different structures and the technologies that are related to that. So basically the textile technology is one of the field that has been constantly undermined when the composites are seen. So these are the various key manufacturing techniques, automated fiber placement, particularly with the industry currently now using that pre-pregs, that automatic fiber placement, automated tape laying, then 2D and 3D weaving technology, robotic dry toe placement, 2D and 3D braiding, along with braid winding and braid weaving. This is something new that is going to come in next 5 to 10 years. That machines are going to come up in the market. Then this based on the dry toe. These all are based on the dry toe. Prepregs can be used, but using prepregs because of the shelf life and other aspects, they are restricted. And to cut down the cost, and country like India, economy like India, where we are more conscious about the cost. So the dry fiber will be more preferred because it can be stored for longer periods, months, and even up to the years after procuring it. It is not going to be waste. But for the pre-preg, maximum 2 to 3 months, and does not and this dry fiber does not require any kind of specialty storing processes like refrigeration or other things which the pre-preg demands. So 2D and 3D knitting technology, inclusive of the warp and weft, these all the technologies that specifically the 2D and 3D and the robotic dry placement. These are key. These are key to the automotive domain, particularly the automotive domain where the higher, more production is required because the number of cars produced in a year are huge. So one industry needs a technology that can give them a very high production rates, which is not possible with any other. If you see the automatic fiber placement, complex algorithms, automatic tape laying also complex algorithms are involved in. So, but with the dry toe placement, it will be quite simple that we see ahead. So these are the overview of the 3D weaving to comparison with the 3D weaving and the 2D weaving. So far, we all are familiar with the processes, but these processes cannot be directly utilized for handling the high performance fibers. The reason why these fibers are very delicate and a slight damage to them can significantly cut down the mechanical properties for which they are intended, or their advantage can be reduced. So these processes through with no doubt the basic infrastructure will remain same, but to handle such fibers, these need to be optimized to that level that they do not interfere with the properties of the fiber, which is the main part of the mechanical property or the strength. So by optimizing by building the purpose-built 3D viewing machines, variety of structures can be formed. Here the orthogonal view, 3D interlock view, 3D layer to layer, and the derivative of these. So all these structures have different properties. So this provides an sufficient room for the exploration and for the students also to do research on those aspects by constantly targeting one application and then seeing which structure is best, and to that structure what other modifications we can do. So that's how the 3D viewing technology, near net shapes can be easily formed, thus reducing part count, which is very important for the automotives, particularly where the large number of components or parts are required and then they are assembled together. Also in the aerospace industry. So 2-3 parts can be combined together and they can be produced in a single process, near net shape. So with also taking care of the waste that is going to be generated. So with least waste, these technologies work on. So no layering needed to get required part thickness. Now today what the industry is using is a single ply woven or satin preforming, which has to be layered to attain the required thickness of the component thickness. So that is suffered with because that is going to suffer with the delamination resistance is very poor, damage tolerance is very poor. There is no any through thickness bindings. So with that kind of things, the researcher is pushed to go towards the 3D viewing portions. Then the abilities of the 3D viewing includes that it can provide you the taper in either in the longitudinal direction or in the transverse directions. So the preforming can be tailored fully through the process, and there are no any custom built things available here so far. Many companies like Donier, which have the this what called solid rapier, particularly they claim that they are weaving the 3D fabrics, but the ultimate process is remaining the same, which lots of fiber damage is inclusive in. Then these are the warp knitting and weft knitting structures. We all are familiar with this, the directionally oriented warp knits, that multi-axial that we call. So far in India, many people are manufacturing, or not many companies are manufacturing. So here also the fibers and can be arranged, and especially I would talk about this weft inserted warp knit. It's for specialty for the medical sides, where slow drug release kind of materials can be incorporated in very easily with the help of this technology. Then this braiding, 3D braiding have some applications in the aerospace, but because of the preforming size is not very popular. Then this is the comparison with the LCM and the tape lying and the automatic fiber placement, which is coupled with the autoclave. But here in the robotic die placement, you are free to put the fiber in any direction. It's at your will. So that's why we call it a bespoke technology, where you can engineer the preforming as per the requirement. And this can be further coupled with the tufting or stitching to provide through the thickness medium, so that the damage tolerance can be taken care of. So simply the liquid molding, this one depositing the fiber onto a grid and then taking off that and converting into the composite. This is a simple, this is another example. You can see that the fibers are placed in different directions. This is a very simple Cartesian robot. Very simple compared to that is used in the aerospace industry, the ATL and AFP. This is very much simple and very low cost technology that can help to design the composites with utmost strength and proper mechanical properties. So composite processing, coming to the composite processing in India has traditionally leaned on autoclave curing for aerospace and defense applications. However, the high capital cost limited size capacity, and energy intensity of autoclaves create barriers for SMEs and restrict the large-scale parts manufacturing. The out of autoclave processing offers low-cost, scalable alternatives that can achieve aerospace-grade quality, where cost sensitive under the vacuum oven or in frozen conditions. For India, where the cost sensitivity and scalability are the crucial, autoclave technologies are becoming the strategic enablers across the aerospace, defense, automotive, rail, marine, and the wind energy. So autoclave produces the high quality composite parts without using high pressure autoclave. This is the advantage of this autoclave technology. Autoclave, there are two alternatives in that. Prepregs can also be produced by using the autoclave processing. This is the basic setup of the autoclave processing. So the lower capital and operating cost with building, maintaining large autoclaves, better scalability and throughput for large structures, new resin chemistries and prepregs now allow autoclave quality to consolidate with the vacuum process. Autoclave processing represents a transformative opportunity for Indian composite ecosystem by lowering the cost barriers and enabling the large-scale, high-performance part manufacturing. Aligned with the Make in India and Atmanirbhar Bharat goals in aerospace, defense, transport sectors, strategic adoption of autoclave technologies can place India in a strong position to supply both domestic and global composite markets over the next decade. The key challenges the composite industry in India is facing is the porosity, void control, and reproducibility. LCM and oven cures are more sensitive to tooling, vacuum integrity, resin flows, cure kinetics, process control, and NDT are essential for that. So that lots of work to be done into this direction so that the property assessment can be done to the finest level. Aerospace qualification, because the composite that is made, whether it is qualified for the aerospace or not, that also need to be certified. Certification is required for that. So far, it's my perception, but may not be correct. Still, we have not attained that level that we can export to some countries. So materials and resin chemistry, lots of work need to be done, particularly in the low viscosity resins, so that the wettability of the preforming can be ensured, so that dry regions within the preforming, thick preformings can be avoided, and a good interface can be built. Tooling and fixture, accurate reputable tooling and vacuum bagging infrastructure is needed. That need to be established. That also the further industry is looking ahead, and maybe in the coming few years, the things may come up. So workforce skills, that also one important aspect. The one thing that I would like to say that the composite is a field or is a material where if your approach is not first time right, you cannot succeed. Because once the polymer is put into the reinforcement, it will end the things. If it is not done properly, and if it is not properly investigated before putting that, then your preforming is gone, your resin is gone, everything is gone into waste, and you cannot recover it. The high cost of automation with that AFP and ATL, limited skilled workforce, material availability, R&D gaps, and standardization. Particular still the BIS has, particularly the BIS I'll talk about. Still, yeah, just 1 minute, sir. Still, the BIS has not done enough in that standard development for the composites. We are working on that, and soon we will be coming out with that. So the indigenization of carbon fiber, we don't have any carbon fiber manufacturing facilities. So that also go with the government policy and the push the private sector along coupling with that. Some of the people are working, industries are working in that, and in coming years we can see the carbon fiber to be indigenized. Automation in preforming, then limited automation in robotics. Robotics industry is also not well touched. As I said, that this is the cheapest method to produce engineered composites. Then composite for EVs and green mobility, export potential with Make in India and PLI schemes. Thanks.
Great, sir. Thank you very much for your so illustrative presentation. And we were running short of time, otherwise we could have enjoyed more. So during lunch, we can discuss, you can catch Dr. Sharma, and definitely we will be taking your expertise through Sika platform and reaching to the new generation people or those who are interested. Like a lot of people are interested in advanced textile and advanced composite. So this is one good area. So thank you very much, Sharma sir. So now I request Sri Kameswar Rao sir to come up on the stage and facilitate Dr. Sandeep Sharma. Thank you, sirs. Now, this is the time to go for a very useful and talk of the day topic for the panel discussion. So, the topic for the panel discussion, which I have already talked to you, scaling up